back, everyone, to another college algebra lecture. Today, we are going to be starting on chapter 11 and begin our discussion regarding sequences and series. For our first section, 11.1, it's all about sequences. And anytime we talk about sequences in the math world, what you need to be thinking about is a pattern. So for our first little exploration on here, I give us a sequence, and what I want us to do is I want us to list out the next four numbers in that sequence. Now, in order to do this, you need to be able to look at it and identify the pattern that's happening. So looking at this first one, I have 4, 5, 9, and 13. What I see going on right here is to get from my first number to my next number, I have to add 4. That is how my pattern is defined. So if I leave off on 13, adding 4, my next number is going to be 17. Adding 4 again, we get 21, and then we get 25, and then we get 29. And then we'll put dot, dot, dot to say that the pattern continues. So here we started with a sequence, we identified the pattern, and then we use that pattern to extend the sequence out 4 more. Now, for our next one, B, we start with 6, 12, 24, and then 48. Here, I could see that I'm adding 6 to get up to 12, but I don't add 6 to go from 12 to 24. So I'm not adding to get to my next number anymore. But I do see that I'm multiplying by 2, because 6 times 2 is 12, and 12 times 2 is 24. So my pattern on this one is to multiply by 2. So continuing on in the same manner, 48 times 2 is 96. 96 times 2 is 192. And then we get 384, and then 768, and so forth. So far we've seen that we can add a number, and we now see that we can multiply by a number. Okay, so now let's take a look at a couple that are a little bit more interesting. So for C, we start with 0, and then we go to 5, and then negative 10, and then 15. So I do see the numbers are changing by 5 each time, but that negative 10 throws a little bit of a kink in here. Well, if I take into account that 0 could kind of be rewritten as negative 0, I see that we're alternating between negatives and positives. So knowing that, I could have negative 20, and then 25, and then negative 30, and then 35, and that is my pattern. My numbers are increasing by 5, and then I'm alternating between positive and negative. Now, this last one's a little bit more interesting. I see that I'm not adding a number, because going from 1 to 4 is plus 3, but 4 to 9 is plus 5, so that's not working for me. I'm not multiplying by a number, and I don't have something where I'm alternating either. But if I look really closely at it, I can see that these are all the squares. This is 1 squared, 2 squared, 3 squared, 4 squared. So once I identify that, my next one is going to be 5 squared, which is 25. And then 6 squared is 36, 7 squared is 49, and 8 squared is 64. And it would continue in that pattern. Okay, so that's basically sequences. A list of numbers that follow a pattern. Now, a couple of things that you need to keep in mind. First off, they have a definite start. If you notice, I don't have the ellipses or the dot, dot, dots going to the left. So I'm not going forever to the left side. I'm only going forever from a starting value. Each one had a definite start. Now, identifying the pattern and continuing on, not too crazy, but what if I ask you, let's say, for the 100th term of a sequence? That means you would have to write out 100 terms, or 92 more based on this. That's kind of a pain in the butt, and we don't want to do that. Well, lucky for us, we could actually write out a function for a sequence, or a formula for it. Either one you can say. So a sequence, instead of writing it out as f of x, we are going to use this notation, a n, where the a, that's the name of our sequence, just like the f of x, the f and f of x, and n, that is the number that we're on. Now, what's special on here, this is a function, But instead of being able to use every single number for n, we only use the positive integers. So we start at 1, and we use 2, 3, 4, 5, so forth, and they go in order. So right here, we're going to use the positive integers, and we start at n equals 1. That's very important. So if I wanted to write out a sequence as a function for d right here, I would say an, this again is the same as saying f of x, that would be the f, that would be the of x. And the way I would define this one is n squared. Because whenever I start with n1, that's where I'm supposed to start. 1 squared is 1. And then I would do 2, that gives me 4, and then 3 squared is 9, so forth. So this is how I could write a function or formula for that sequence. All right, so now that we know that we can write on our sequences as formulas or functions, then let's go ahead and write out the sequence based on the formula. So looking at this first one, I have an equals 5n plus 2. So let's write out the first 5 terms. Well, if I want to write out my first 5 terms, I need to start with n equals 1. So substituting 1 in here, I have 5 times 1 plus 2, and that gives me 7. Now my next number I have to use is n equals 2, because they have to go in order. The order is very important. So I have 5 times 2 plus 2, that gives me 12. And then from there, we have to use n equals 3. We have 5 times 3 plus 2, that gives me 17. Now, I could do this 2 more times to get all 5 numbers, but after 3 numbers, you can identify a pattern. My pattern on here is I see I'm increasing by 5 each time. So now I can just go ahead and write everything out. I have 5, 12, 17, and my pattern is to do plus 5, so I have 22, and then 27, and so forth. All you need to identify a pattern are 3 numbers. Once you get your 3 numbers and you can spot the pattern, you just go ahead and finish it out from there. All right, let's take a look at B now. This one, our sequence Bn equals 2 times 1/5 to the n minus 2 power. Now, starting again, if I want to list these out, I'm going to have to start with n equals 1. So I have 2 times 1/5 to the 1 minus 1 power. Well, 1 minus 1 is 0. 1/5 to the 0 power is just 1, so it goes away. We just get 2. All right, now I'll do n equals 2. So I have 2 times 1/5 to the 2 minus 1 power. 2 minus 1 is 1. A number to the first power stays the same. So I have 2 times 1/5, which gives me 2/5. Okay, now let's do one more and see if we can identify the pattern. So I have 2 times 1/5 to the 3 minus 1 power. Well, 3 minus 1 is 2, so I'm going to have 1/5 squared, which is 1 over 25. I have 2 over 25. All right, so looking at this one, I noticed a pattern, but just in case you don't, check it out. 2 can be written as 2 over 1. Do we see that the numerator is staying the same? It's 2 every time. In the denominator, I can go from 1 to 5 and 5 to 25. I'm multiplying by 5. So my pattern right here, I have 2, and then 2 over 25, or 2 over 5, then 2 over 25. Next one, the numerator is going to stay the same because that's my pattern, and I'm going to take my denominator, I'm going to multiply it by 5, and I get 125. And then my next one, 2 is still the same. I multiply the bottom by 5, and I get 625. Now, this one, just in case you didn't identify what the pattern was and continue from there, you still can go ahead and just put in 4 for n and then 5 for n and still get what you need. But work on trying to identify the pattern. All right, now for the next one, Cn equals negative 1 to the n power times 2n. This one's kind of fun. So starting the same way, we're going to put 1 for n. So I have negative 1 to the first power times 2 times 1. Well, negative 1 to the first power is still negative 1. And 2 times 1 is 2, so I got negative 2. And now I'll use n equals 2. So I have negative 1 to the second power times 2 times 2. Well, negative 1 to the second power, a negative to an even exponent is going to come out as a positive. So I have positive 2 times 2 is 4, positive 4. Now I have 3. So we have negative 1 to the third times 2 times 3. Well, 2 times 3 is 6. And a negative to an odd power is going to come out negative. So I have negative 6. Now, stopping and looking at it, I see a pattern. These are the even numbers, or numbers that are multiples of 2, and it's alternating negative to positive. So my pattern right here, I have negative 2, 4, negative 6, 8, negative 10, and so forth. All right, now it's time for the last one. So my sequence dn is defined as n if n is odd and n squared if n is even. So for this one, starting the same exact way as the others, I'm going to start with n equals 1. Well, 1 is an odd number, so I use this. So I just get what n is, which was 1. Next up, I'll use 2. Well, 2 is an even number, so I have to use this part. So 2 squared is 4. Now 3. 3 is odd, so I have to use the top one, and I get 3. Well, 1, 4, 3, that's not the easiest to spot, so let's do one more. So I have 4. Well, 4 is an even number, so I put it in this one, and I get 16. Now I can kind of see our pattern. Our odd numbers stay the same, and our even numbers are squared. So I have 1, 4, 3, 16. Next is 5. 5 is odd, and that stays the same. And if I need to do another one, I would have 6, which is even, so I'd have 36. So I just need to know that I'm alternating between the number staying the same and the number being squared. All right, so this has been a basic introduction of sequences. We can continue a pattern if we see what it is, and if we see a sequence defined as a function or as a formula, then we can list out numbers based on that. So the next thing we're going to do is we are going to begin focusing on 2 specific types of sequences that we're going to use for this class. These 2 sequences, the first one is called an arithmetic sequence, which, yes, I know that's spelled the same way as arithmetic, but we're going to pronounce it as arithmetic. And the other one is geometric. Now, these 2 sequences are probably on the more basic side and really user-friendly. And the way that they differentiate from each other, for an arithmetic sequence, what we do is we add or subtract by the same number. So for arithmetic, we add or subtract. And for geometric, you will multiply or divide by the same number. All right, arithmetic, add or subtract, geometric, multiply or divide. Now for both of these, we see that it says by the same number. That same number has a particular name for each one of these. So for arithmetic, the number that we will add or subtract by, that is called the common difference. And the letter we use to denote that is D. And for the geometric sequence, the number that we multiply or divide by is called the common ratio. And the letter we use for that is R. All right. Now, I put the technical definitions of these, but they're a little bit more detailed and one's actually a little bit more user-friendly. So arithmetic, you add or subtract by its number. That number is a common difference. geometric, we multiply or divide by the same number, and that is called the common ratio. Now, if you ever need to figure out what the common ratio or the common difference is, these little formulas right here will help you out. So down here at the bottom, we're going to put down how to find the common difference. So find common difference. The way we, the way we do it is D will be equal to whatever your current term is minus your previous term. And the way that we can find our common ratio is very similar. So find the common ratio R. R will be equal to your current term divided by your previous term. That's how you do it. So once you look at a sequence and you figure out whether it's going to be arithmetic or geometric, whether we're adding something or multiplying by something, we can figure out what the common difference is by taking whatever our current term is and subtracting off the previous, or we can find our common ratio by taking our current term and dividing by our previous. Now, if you're not quite following, let's look at some examples that have numbers in it, and it should hopefully make a little bit more sense. All right, so for this example, what we're going to do is we're going to first determine whether a sequence is arithmetic or geometric. If it's arithmetic, we're going to list out our first term and our common difference. If it's geometric, we're going to list out our first term and the common ratio. So looking at our first one right here, I have 4, 2, 0, negative 2. Now, just looking at it, I can see that we're decreasing by 2 each time. Now, if you don't quite see that, what you can do is you can do a little test. I can check to see if it's arithmetic by finding a common difference. The way we do it, so I'm going to take my current term and subtract off the previous. Well, if I'm standing on 4, there is no previous term behind it, so I can't start there, but I can start at 2. So if I start at 2, my previous term is 4. So I can do 2 minus 4. That gives me negative 2. All right. Now, if this sequence is arithmetic, when I do this again, I'll get negative 2 again. So standing on 0, I'll subtract off my previous term, which is 2. That gives me negative 2. Those two are the same. So whenever I do a check for a common difference, if it comes out the same, that's how much I'm changing by. And not only that, the number that I got out, that is my common difference, D. So this one is arithmetic. My first term, what we use for that is A1, because remember, if n is 1, that's where we start. So A1 is 4, and my common difference is negative 2. That's all it is. And again, the A1, that will always be our first term because n is 1, and that's where we always start. All right, so now let's take a look at B. On this one, they're not listed out for us, but I can go through pretty quickly and list them out because we saw how to do that on the previous page. I would always start with n equals 1. So if I substitute 1 in for n, 1 minus 1 is 0, so 3 is going to go away, and we get 2. Now I'd use n equals 2. 2 minus 1 is 1. 3 to the first power is still 3. So 3 times 2 is 6. And now I need 3 numbers to identify a pattern. So I'm going to do this again. So I'll do it for the third. So I'll put 3 up here. 3 minus 1 is 2. 3 to the second power is 9. Times 2 is 18. And I don't have to do any more than that because 3 numbers are all I need to get a pattern. Okay, so looking at this one, I go from 2 to 6 and 6 to 18. This one definitely does not look arithmetic because I'm not adding by the same number each time. But again, just in case you don't see that, you can do a little test. I can do 6 minus 2, that gives me 4. And then 18 minus 6, that gives me 12. That is not the same. So since those aren't the same, this one is definitely not arithmetic. So now let's do a check to see if it's geometric. So if it's geometric, I can take my current 6 and divide by my previous 2. That gives me 3. And then I can do it again. 18 divided by 6. That gives me 3 again. Since they are the same when I did division, this one is geometric. And my common ratio is 3. All right, so this one is geometric. And my first term when I listed them out was 2, and my common ratio is 3. And that's all you got to do. Now, I will go ahead and tell you this part, just in case doing all this in your head wasn't your best friend. You can use your calculator to help you out on that. So right here, I could have done 2 times 3 and raised that to the 1 minus 1 power, and that gave me 2. And then we can do it again and change that to a 2, and that can give me 6. So if doing the mental math is not your strong suit, please feel free to use your calculator, type it in, and then list out your numbers. All right, so you've seen how to do 2 of these. What I would encourage you to do right now, pause the video and go ahead and try C and D on your own. See if you can figure those out. All right, so now continuing on, let's take a look at C. Looking at this one, just eyeballing it, I can definitely tell this one's not arithmetic because I'm not adding the same number. So I'm going to skip testing the arithmetic part and go straight into testing for geometric. So to test to see if this one's geometric, I'm going to have 3 over 10 divided by 1 over 5. This gives me 3 over 2. Okay, and now doing it again, I have 9 over 20 divided by 3 over 10. That winds up giving me 3 over 2 also. Those are the same. So since it is the same, whenever we did this, we know R is going to be 3 over 2. Therefore, this one is geometric. Our first term is 1/5, and our common ratio is 3 over 2. And that's all you got to do. All right, now moving on to the next one. So right here, we don't have them listed out, but we can figure out what we need. So using n equals 1, I have 6 times 1 is 6, plus 4 is 10, and then 6 times 2 is 12, plus 4 is 16, and then 6 times 3 is 18, plus 4 is 22. Looking at this one definitely looks arithmetic because I can see that I'm adding 6 each time. So I'm going to not bother checking geometric. And just to make sure, I am going to do my little test. I have 16 minus 10 gives me 6. And then 22 minus 16 gives me 6 again. Those are the same. And that is my common difference. So now I know this one is arithmetic. My first term, A1, is equal to 10. And my common difference D is 6. And that's all it takes. All right, so far we've been able to extend out a sequence. Once we identify the pattern, we can take a sequence that's defined as a function and list out numbers. Now we can identify whether a sequence is arithmetic or geometric. Now, before we go on to the next page, just in case anyone was a little confused on how to do this part right here, you're more than welcome to type it into your calculator. So if you want to do your calculator, we can do 3 divided by 10, close my parentheses around that, divided by 5 divided by, or 1 divided by 5. And we can change that into a fraction. We get 3 over 2. Now, if you want to do it by hand, which I encourage you to learn how to do, you need to remember that if you divide by a fraction, that's where you have to do what your teacher in the past said, keep, change, flip. So keep, change, flip means the numerator stays the same. We keep it the same. We change from division to multiplication, and then we flip the denominator. Doing it this way, I see the 5 will cancel with the 10 and turn that into a 2. So I have 3 over 2. That's just a little side thing if you didn't see how to do it. All right, so now that the little baby math lesson's over, let's continue on to the next page. All right, so what we're going to do next is we're going to go back to that question I asked on the front page. What if I asked you for the 100th term of a sequence? Now, as we just saw on the previous page, if we have a formula for it, then it's not too bad. But right here, what if you don't already have the formula? So in this case, I'm going to give you sequence listed out. We are going to start writing a formula for it. Then on the next page, we'll use that formula to find a particular term. All right, so if you have an arithmetic sequence, the way you can find the formula for it is this. AN is going to equal A1, which is our first term, right there, plus N minus 1 times D. And again, D is the common difference. I'm going to abbreviate that down to just diff. If you have your first term and your common difference, you can find the formula for this. Now for geometric, it's going to be very similar. AN equals A1, which again is our first term, times R, which is our common ratio, raised to the n minus 1 power. Now, it's very important that you notice that the n minus 1 is only on the R. It's not on the A1. That is going to be very important to us. And a good rule of thumb, it's not always needed, but it's not going to hurt you if you always put the parentheses around your common ratio. So it's just pretty good to keep on there. All right, so what we're going to do for this example, we're just going to write the formula for each of these sequences. Looking at the first one, the very first thing we have to do is just determine if it's arithmetic or geometric, because that's going to tell me which of the formulas I have to use. So looking right here, 5, 12, 19, 26, I see that I'm going up by 7 each time, so this one is arithmetic. All right, so since it's arithmetic, I know one thing I'm going to need is my first term, A1. Luckily, that's already listed out for me, so I know that's 5. Next thing I need is my common difference, D. So to find D, I see that we're going up by 7, so if you just want to write 7, go for it. If you want to double check yourself, I can do 12 minus 5, and that gives me 7. All right, now we're going to use this formula up here. So I have AN equals my first term 5 plus n minus 1 times our common difference 7. Now on this one, I will require you to simplify. And to simplify, I need to notice that this parentheses n minus 1 is touching a number 7. That means I can technically distribute this 7 over to both of those. So now we have AN equals 5 plus 7n minus 7. Combining like terms, I have AN equals 7n minus 2. And that is the formula for my sequence. And if you want to double check yourself, you can always plug in N1. If I do that, I have 7 times 1 is 7, minus 2 is 5. That's what I ended up with. All right, that's all you got to do. Now for the next one, looking at this, I have 3, 6, 12, 24. This one, I'm not adding by the same number each time, so it's not arithmetic, but I do see that I'm multiplying by 2, so this one is geometric. So for geometric, I need my first term. So my first term, A1, is 3. Then I need my common ratio, R. So I can get that by taking my current 6 dividing by my previous 3, and we get that it's 2. Now we can write out our formula. I have an equals my first term 3 times 2 to the n minus 1 power. And we're done. Here, there is nothing we can do in terms of simplification. We're going to leave it just like that. And that's all there is to it. And at this point, I want to point something out to you that I've kind of been glossing over for the previous 2 pages. Whenever you have an arithmetic sequence, when you write it out in its formula form, it's going to look linear. Do you notice that this is of the form mx plus b? Every arithmetic sequence is going to look like that. And your common difference is going to be what the slope is. Because slope, that's your rate of change, that's how much you change by. That's exactly what your common difference is. So right here, my common difference 7, that's how much I'm changing by. That's my slope for this. So on the previous page, right here, we saw that this one was arithmetic with a common difference of 6. I knew that from the beginning because this one was linear and 6 was my slope. And if you have a sequence that is exponential, such as this one right here, we know it's exponential because our variable is in the exponent, that's guaranteed to be geometric, at least for this class. And my common ratio is always going to be the base of the exponent part. So here my base is 2, that's my common ratio. Looking at this previous page, this one's exponential and it was geometric. The base of my exponential was 3, my common ratio was 3. These are quick and easy ways that you can identify them. So if you ever get one that looks linear, it's guaranteed to be arithmetic and your slope is your common difference. And if you ever get one that looks exponential, it's going to be geometric and the base is going to be your common ratio. All right, so now that you've seen 2 examples, you should probably pause the video and go ahead and give C and D a try on your own. All right, so taking a look at C. For this one, I can see that I'm going down by 10 each time. Since I'm going down by 10, this one is going to be arithmetic. I know I need my first term. A1 is going to be 34. My common difference, since I'm going down by 10, it's going to be negative 10, but just in case you need to calculate it, 24 minus 34 equals negative 10. Got it? Okay, so finding everything I need, my formula for this, an is going to be equal to 34 plus n minus 1 times negative 10. Distributing my negative 10, I have 34 minus 10n plus 10. And now my final answer is going to be negative 10n plus 44. And we are done. Alrighty, so looking at the next one, I have 1, negative 1/4, and then positive 1 over 16, and then negative 1 over 64. This one is definitely geometric. So being geometric, I know I'm going to first need my first term. So A1 is 1. And now I need my common ratio. I have negative 1/4 divided by 1. Well, a number divided by 1 is still going to be the same, so negative 1/4. Now writing out my formula, I have 1 in front of the parentheses. Well, a 1 in front of parentheses doesn't have to be there, so I'm going to leave it off. And in parentheses, negative 1/4 to the n minus 1 power. And that's my answer. Now, if on a test for me, you were to leave the 1 in front, I wouldn't count off for it, but I would frown just because it's not proper form. But you're not technically wrong. All right, so now we've seen how you can take a sequence that's listed out and then make a formula for it. And the last thing we're going to do on here is we're going to take those formulas and use them to find a particular term in a sequence. So looking at example 4, I want to find the 16th term in the sequence 5, negative 2, negative 9, negative 16. And I definitely do not want to write out 16 terms on here. So the first thing that we're going to do is we're going to go through and find the formula for this. Then we're going to use that formula to find the 16th term. Now looking at this one, I can see that I'm going down by 7 each time. So this one is arithmetic. And for the arithmetic part, I need the first term, which luckily is listed out for us as 5. I need my common difference. So I have 5, or sorry, not 5. I wrote that out wrong. I have negative 2 minus 5, which gives me negative 7. All right. So an is going to equal 5 plus n minus 1 times negative 7. So I have 5 minus 7n plus 7. And that gives me negative 7n plus 12. Okay, so that is my formula for this one. Now I need to find the 16th term on here. So that just means I need to do a16. So I have negative 7 times 16 plus 12. And doing this, we wind up getting that it's negative 100. You can do mental math if you want, or please feel free to type it into your calculator. That's all it is. That's all you got to do. All right, so now let's do another one. For example 5, what I want us to do is I want to find the 8th term of the sequence 3, negative 21, 147, negative 1029. So just eyeballing this one, I see that it's alternating between positive and negative. So that is definitely going to be geometric. So I got a geometric one right here, and I know I'm going to need my first term, which is going to be 3. My common ratio, I have negative 27 divided by 3. That gives me negative 7. Again. Now, I can write out my formula. an equals 3 times negative 7 to the n minus 1. And that's our formula. Now we need the 8th term of this one. So I have a8 equals 3 times negative 7 to the 8 minus 1 power. This one, we're going to need to type into the calculator. So doing this, I have 3 times negative 7. Make sure you put your parentheses on there. It makes a big difference. Raised to the 8 minus 1 power. And we get that it is a big number. So that's negative 2,470,629. And that is our answer. All right. So now you've seen 2. At this point, as usual, I'm going to encourage you to pause the video and try examples 6 and 7 on your own and see if you can get the same answer that I get. All right. So for example 6, looking at this one, I want to find the 41st term. And looking at my sequence, 2, 6, 10, 14. This one is arithmetic because I am increasing by 4 each time. So for arithmetic, I need my first term, which is 2, my common difference. Pretty easy to spot that it's 4. Got it. Now I can write out my formula. an equals 2 plus n minus 1 times 4. That gives me 2 plus 4n minus 4. And we get 4n minus 2 as our formula. Now to find the 41st term, so I have a41. That is going to be 4 times 41 minus 2. Doing this, we get that it is 162. And that's it. That's what you should get for the answer. Okay, now for the last one. I want to find the 6th term of the sequence, and our sequence is 4, 12 over 5, 36 over 25. Well, this one definitely looks geometric. Okay, so I know the first thing I'm going to need is my first term, a1, which is 4. Now for my common ratio, we have 12 over 5 divided by 4 You can type in the calculator or you can do it by hand. Either way, you're going to get 3 over 5. Now for our formula, an, this is going to be 4 times 3 over 5 to the n minus 1 power. We're looking for the sixth term, so I have a6 equals 4 times 3 over 5 to the 6 minus 1 power. And like most geometric stuff, we're going to need to type it in. So I have 4 times 3 over 5 to the 6 minus 1. And we get that is 972 divided by 3,125. And that's your answer. Now, just in case your calculator doesn't give it to you as a fraction right off the bat, you could have typed in 4 times 3 divided by 5, and we'll raise that to the 6 minus 1 power. You'll get a decimal. To change a decimal into a fraction, if you have a TI, you'll press the math button right under alpha. First option, fraction, enter, enter, and that'll give you the fraction that you need. And that's it. That is our basic introduction to sequences. If you have any questions, please feel free to contact me. And the homework for this is posted, and give it a go. Have a great rest of your day.